Imagine a world where the mighty Tyrannosaurus Rex, once the undisputed king, faced true challenges. In the Hell Creek ecosystem 66 million years ago, herbivores like Triceratops and Ankylosaurus fought back fiercely. Armed with deadly horns and tail clubs, these plant eaters made every hunt risky for T-Rex. In this complex prehistoric world, herbivores didn't just flee. They were often as dangerous as the apex predator itself. For over a century, Triceratops, with its iconic three-horned face, has captured our imaginations. This prehistoric giant, with a skull that made up nearly a third of its body length, has some surprising anatomical features. While Triceratops is famous for its three horns, only two were true horns. The larger horns, positioned above the eyes, were bony growths covered in keratin, similar to the horns of modern cattle or rhinos, and could grow up to a meter long. The third horn, found on the snout, was actually made of fused nasal bones rather than horn material, revealing the complexity of its anatomy. As Triceratops aged, its horns evolved. Juvenile specimens had shorter, straighter horns that grew longer and curved forward with maturity. This change not only altered its appearance, but also likely affected its behavior and social interactions. Triceratops' headgear was a vital adaptation in the dangerous world of the late Cretaceous, where it lived alongside predators like Tyrannosaurus rex. The massive brow horns and the frill at the back of its head formed a defensive weapon that could challenge even T-Rex. When threatened, Triceratops could charge, using its horns to inflict severe damage on attackers. Fossil evidence supports this defensive strategy, with T-Rex bones showing puncture wounds matching the size and shape of Triceratops' horns. This suggests that Triceratops may have successfully warded off even the most fearsome predators. Its horns could have influenced T-Rex hunting behavior, making the predator reconsider attacking a fully grown Triceratops. Triceratops' frill, as iconic as its horns, remains another subject of scientific debate. Its purpose and role in the dinosaur's life continue to intrigue researchers today. The Triceratops is renowned not only for its iconic three horns, but also for the massive frill extending from the back of its skull. This shield-like structure, often larger than a car door, has been a focal point of scientific debate for decades. While early theories suggested its primary role was defensive, recent studies have uncovered a more complex and fascinating array of functions. The frill's purpose has sparked multiple competing theories. Some paleontologists maintain that it served as a defensive mechanism, pointing to fossilized Triceratops skulls showing healed injuries and bite marks from Tyrannosaurus rex. These marks suggest the frill absorbed blows during combat, possibly protecting the dinosaur. However, the discovery that parts of the frill were surprisingly thin, almost paper-like, has led others to question its effectiveness as a true shield. An increasing number of researchers now believe the frill's function went beyond just defense. They propose that its large surface area and distinct shape made it an ideal structure for visual display. Much like the elaborate antlers of modern animals such as deer, Triceratops' frill may have been used for species recognition, attracting mates, or establishing dominance within herds. Evidence supporting this theory comes from the variation in frill shapes and sizes among different Triceratops specimens, indicating that the frill played a key role in signaling to others of its kind. Further complicating the picture, some researchers have speculated that the frill could have aided in thermoregulation. With its extensive network of blood vessels and large surface area, the frill might have helped Triceratops manage its body temperature in the warm Cretaceous climate. The prevailing theory today suggests the frill was multifunctional. It likely served as both a defensive barrier and a visual display, helping Triceratops survive and thrive in the perilous world of the late Cretaceous. This dual-purpose adaptation gave it a distinct advantage in protecting itself from predators, while also asserting its place in social interactions. Triceratops's impressive frill is just one aspect of its remarkable adaptations. To fully appreciate this dinosaur's prowess, we must also consider its massive size and how it stood up to the threats of its time. Now that we've explored Triceratops' impressive horns and frill, let's focus on its locomotion and lifestyle. Recent studies have challenged long-held assumptions about this prehistoric giant. revealing a creature far more dynamic than its tank-like appearance might suggest. New research into Triceratops' skeletal structure and musculature has provided fascinating insights into its posture and movement. Unlike earlier depictions that showed Triceratops with sprawling lizard-like limbs, we now know that it maintained a more upright stance during movement. The elbows were flexed and held close to the body, slightly bowed outwards. This positioning would have allowed for more efficient movement, distributing the animal's weight more evenly and reducing the energy required for locomotion. While Triceratops certainly wasn't winning any speed records in the Cretaceous, it may have been more nimble than previously thought. Its strong leg muscles and efficient posture suggest that it was capable of short bursts of speed when necessary, particularly for defense against predators. When we compare Triceratops to its potential predator, Tyrannosaurus rex, we begin to understand why this herbivore was more than capable of holding its own. While T-Rex was undoubtedly a fearsome predator, reaching lengths of up to 40 feet, it didn't significantly outweigh Triceratops. This relative size parity, combined with Triceratops' defensive weapons and potential for charging, meant that any encounter between these two titans was a high-stakes battle with no guaranteed outcome. As we continue to unravel the mysteries of Triceratops' physiology and behavior, we're left with a picture of a creature perfectly adapted to its challenging environment. Its surprising agility and formidable weapons made Triceratops a true survivor in the harsh world of the late Cretaceous. To truly understand Triceratops' place in the prehistoric ecosystem, we need to explore the landscape it called home. What kind of environment did Triceratops inhabit, and how did this shape its evolution and behavior? The Hell Creek Formation was a world unlike any we see today. This unique environment was the stage for an epic drama of survival that challenged even the mighty Tyrannosaurus rex. North America's geography during this period was dramatically different, with the western interior seaway splitting the continent and creating a narrow strip of land called Laramidia along the western coast. This seaway influenced local climates, fostering a warm, humid environment that supported diverse plant life. The flora of the Hell Creek Formation represented an evolutionary transition, with ancient conifers, ferns, and cycads coexisting alongside the emerging angiosperms, or flowering plants. This shift in plant life had far-reaching effects on the entire ecosystem, providing new food sources and habitats for various animals. The rich biodiversity created a fiercely competitive environment where Triceratops had to defend against predators and compete with other herbivores for resources. The climate of the late Cretaceous Hell Creek ecosystem was generally warm and humid, with seasonal variations. Fossil evidence suggests a subtropical climate, similar to parts of the modern southeastern United States. This environment supported lush vegetation, but also presented challenges such as periods of drought and other environmental stresses. Triceratops played a crucial role in this complex ecological tapestry. As a large herbivore, it significantly impacted plant communities, potentially shaping the landscape through its feeding habits. Its size and defensive capabilities also made it a formidable opponent for predators, influencing the hunting behavior of carnivores like Tyrannosaurus rex. The diverse Hell Creek ecosystem challenged T-Rex's dominance in several ways. Well-defended prey like Triceratops meant that even the tyrant lizard king couldn't hunt without risk. The abundance of other large herbivores and the presence of competing predators created complex predator-prey dynamics, complicating T-Rex's position at the top of the food chain. This prehistoric world was a dynamic, ever-changing ecosystem where survival demanded constant adaptation. Triceratops, with its impressive size and defensive features, was well equipped to thrive in this challenging environment. To fully understand its role in the late Cretaceous ecosystem, we need to examine its diet and feeding habits more closely. When you think of a lawnmower, you might imagine a noisy machine in your backyard. But millions of years ago, a living, breathing lawnmower roamed the earth. Triceratops, with its beak-like mouth and powerful jaws, was nature's own landscaping marvel. This prehistoric herbivore possessed a set of feeding adaptations that were truly remarkable, even by dinosaur standards. At the front of its massive skull was a sharp, parrot-like beak, perfect for snipping off vegetation. Behind this beak, Triceratops had an astonishing dental arrangement known as a dental battery. This structure consisted of columns of teeth, with each tooth being replaced as it wore down. This constant renewal ensured that Triceratops always had fresh teeth ready for action, allowing it to process vast amounts of tough plant material day after day. The teeth of Triceratops were leaf-shaped and designed for shearing rather than grinding. This unique shape suggests that Triceratops was well adapted to consume fibrous plant material, including the ferns and cycads that were abundant in its late Cretaceous environment. Its robust jaws could apply significant force, effectively slicing through vegetation that would challenge other herbivores. Fossil evidence provides clues about Triceratops' feeding behavior. It appears that this dinosaur primarily targeted low-lying plants, using its beak-like mouth to grasp and pluck vegetation from the ground. This feeding strategy would have put Triceratops in direct competition with other large herbivores of its time, such as the duck-billed hadrosaurs. However, Triceratops' unique dental adaptations may have allowed it to process tougher plant materials that other herbivores couldn't handle. The dietary needs of Triceratops were substantial, befitting its enormous size. Studies suggest that an adult Triceratops may have needed to consume around 60 kilograms, 130 pounds, of plant matter daily. Such a high intake would have been necessary to meet the nutritional demands of its massive body, especially given the fibrous nature of its diet. Interestingly, wear patterns observed on Triceratops' teeth suggest that they engaged in some form of chewing. The wear on the face of the tooth crown, rather than just the tip, implies that Triceratops processed its food more thoroughly than previously thought. This behavior would have enhanced its ability to extract nutrients from tough plant materials, a crucial advantage in its ecosystem. Triceratops' role as a herbivore in the late Cretaceous ecosystem was far from passive. Its feeding habits would have had a significant impact on the plant communities of its time, potentially shaping the landscape through selective browsing. Moreover, its ability to process tough plant materials that other herbivores couldn't may have given it a unique ecological niche. Triceratops' feeding adaptations gave it a crucial edge against predators like Tyrannosaurus rex. Its ability to efficiently process large amounts of plant material allowed it to maintain the massive body size that served as its primary defense. Combined with its iconic horns and frill, Triceratops' dietary adaptations made it a formidable opponent in the competitive world of the late Cretaceous. As we consider Triceratops' impressive feeding apparatus, questions arise about other aspects of its life. Did these enormous creatures live solitary lives, or did they form herds for protection and social interaction? To answer this, we must examine the fossil record for clues about the potential social dynamics of these fascinating prehistoric giants. The social behavior of Triceratops, one of the most iconic herbivores of the late Cretaceous, remains a subject of intense debate among paleontologists. For decades, the predominant view was that these three-horned giants led solitary lives, based on the isolated nature of most Triceratops fossil discoveries. This interpretation set Triceratops apart from many other herbivorous dinosaurs of its time, which often showed clear evidence of herd behavior. However, recent discoveries have begun to challenge this long-held assumption. A remarkable find in Wyoming in 2013 unearthed over 1,200 bones belonging to at least 5 Triceratops individuals, suggesting these animals may have traveled together. Additionally, a bone bed in southeastern Montana contained the remains of 3 juvenile Triceratops, indicating that young individuals may have formed small groups or family units. Despite these findings, the overall scarcity of Triceratops mass graves compared to other herbivorous dinosaurs continues to puzzle researchers. Paleontologist Paul Barrett notes that the predominantly isolated nature of Triceratops fossils is unusual when compared to other plant-eating dinosaurs of the time. Several theories have been proposed to explain the potential advantages of group living for Triceratops. Herd behavior could have provided enhanced protection against predators like Tyrannosaurus rex, with a group of adult Triceratops presenting a formidable defense. Additionally, living in groups could have facilitated more efficient foraging. Alternatively, some paleontologists propose that the apparent solitary nature of Triceratops could be due to ecological factors or specific predation pressures. The presence of large theropods like Tyrannosaurus rex may have influenced Triceratops' behavior, potentially leading to a more dispersed population to avoid attracting the attention of these apex predators. Evidence of injuries on Triceratops fossils, including puncture wounds from other Triceratops, suggests that these animals engaged in combat with each other. This behavior indicates social interactions beyond mere coexistence, possibly related to territorial disputes or mating rituals. Such interactions imply a level of social complexity that goes beyond simple herd behavior. As research continues, the scientific consensus on Triceratops' social behavior remains in flux. While recent discoveries suggest more social interactions than previously thought, the overall picture is still unclear. What we can say with certainty is that Triceratops' social dynamics were likely more complex than initially assumed, potentially varying based on age, season, or environmental factors. This ongoing debate about Triceratops' social behavior adds another layer of intrigue to our understanding of these prehistoric giants. As we consider whether T. rex was more likely to face off against a solitary Triceratops or a defensive herd, we're reminded of the complex interactions that shaped the ecosystem of the late Cretaceous. These interactions extended beyond predator-prey relationships, encompassing a wide range of encounters with other species in their prehistoric world. The iconic clash between Triceratops and Tyrannosaurus rex has long captured our imaginations. But the reality of these prehistoric encounters was far more complex than popular depictions suggest. Fossil evidence provides intriguing insights into these interactions. A particularly compelling specimen, collected in 1997, reveals a Triceratops horn bitten off during an attack. Yet the animal survived, highlighting its resilience in the face of predation. The frequency of combat-related injuries in Triceratops fossils is noteworthy, with studies indicating that approximately 14% of skulls exhibit damage or lesions. This high incidence suggests that violent confrontations were a regular part of Triceratops' life, whether with predators or conspecifics. While T. rex possessed formidable predatory adaptations, including powerful jaws and serrated teeth capable of inflicting devastating wounds, taking down a full-grown Triceratops was likely a high-risk endeavor. Paleontologist Robert Bakker eloquently described these prehistoric battles. No matchup between predator and prey has ever been more dramatic. It's somehow fitting that those two massive antagonists lived out their co-evolutionary belligerence through the last days of the last epoch of the age of dinosaurs. This description captures the epic scale of these confrontations, which were the culmination of millions of years of evolutionary arms race. As ongoing research continues to refine our understanding of these prehistoric interactions, it's clear that encounters between Triceratops and T. rex were far from one-sided affairs. These confrontations were likely tense, strategic, and fraught with danger for both participants, a stark contrast to simplistic media portrayals. While interspecies conflicts capture our imagination, they represent only one facet of Triceratops' combative nature. The high incidence of combat-related injuries in Triceratops fossils suggests that these powerful creatures engaged in frequent conflicts with their own kind. As we explore Triceratops' intraspecific interactions, we uncover even more surprises about the social dynamics of these fascinating prehistoric giants, further expanding our understanding of their complex lives in the late Cretaceous world. While Triceratops' battles with Tyrannosaurus rex have captured our imagination for decades, fossil evidence reveals an equally fierce opponent, other Triceratops. The bones of these iconic horned dinosaurs tell a tale of bone-crushing impacts and shattered horns, not from encounters with predators, but from conflicts within their own species. Paleontologists have been intrigued by the combat-related injuries found in Triceratops fossils. These injuries, often found on the frill and cheekbones, bear the unmistakable signs of horn impacts from other Triceratops. This discovery challenges our assumptions about the purpose of Triceratops' impressive headgear. While the horns and frills served as effective defenses against predators, they appear to have been equally important in conflicts between rival Triceratops. The reasons behind these confrontations are still debated in the paleontological community. Some researchers propose that these battles were primarily territorial, with Triceratops using their formidable horns to establish and defend feeding grounds. Others argue that these conflicts were more likely related to mating rituals, with males engaging in combat to establish dominance and earn the right to mate. As we examine the social dynamics of Triceratops, a picture emerges of a complex and potentially hierarchical society. The frequency and intensity of these conflicts suggest that social status was a crucial aspect of Triceratops' life. Whether for territory, mates, or both, Triceratops individuals would have needed to prove their strength and dominance regularly throughout their lives. This new understanding of Triceratops' behavior adds another layer to our appreciation of these magnificent creatures. Far from being simple prey animals, Triceratops were active participants in a dynamic and competitive social environment. Their impressive horns and frills served multiple purposes: defense against predators, weapons in intraspecific combat, and possibly even as displays of fitness for potential mates. As we continue to unravel the mysteries of Triceratops' social life, we're left with a vivid image of a prehistoric world filled with epic confrontations. These battles not only shaped their evolution and behavior over millions of years, but also raise intriguing questions about their life cycle. How did a Triceratops grow from a vulnerable hatchling to a battle-scarred adult? To answer this question, we must turn our attention to the fascinating journey of these prehistoric giants, from egg to apex herbivore. While Triceratops is widely recognized for its impressive size, its remarkable growth strategy was essential for thriving in the dangerous world of the late Cretaceous. Starting life as a hatchling no larger than a house cat, Triceratops underwent a staggering transformation, reaching up to 12 tons in adulthood. This extraordinary growth was a key survival adaptation, but also presented its own set of challenges. Paleontologists have studied Triceratops' growth through the microstructure of fossilized bones. The bones of young Triceratops show signs of rapid growth, with dense blood vessels indicating high metabolic activity. This suggests that young Triceratops invested considerable energy into growing quickly, likely as a defense mechanism to avoid predators. Unlike some other dinosaurs that grew steadily throughout their lives, Triceratops followed a more complex growth pattern. Evidence indicates that the species passed through distinct life stages, each with varying growth rates and physical changes. However, the scarcity of juvenile fossils has made it difficult to fully understand their early life. The few fossils that have been discovered show that young Triceratops had smaller, underdeveloped horns and less pronounced frills, features that grew more elaborate over time. To survive in the perilous Hell Creek ecosystem, home to dangerous predators like Tyrannosaurus rex, Triceratops utilized several survival strategies. Rapid growth allowed young individuals to develop their defensive features quickly, and some researchers speculate that juveniles lived in small groups for protection. Additionally, their plant-based diet may have minimized time spent exposed in open areas, reducing the risk of predation. As Triceratops matured, its growth rate slowed, with energy directed toward developing its iconic features. The horns and frill, initially modest, became larger and more intricate, improving its defensive abilities and likely aiding in social interactions and mate selection. Triceratops' unique growth and maturation process exemplify its evolutionary adaptation, helping it thrive in one of Earth's most dangerous ecosystems until the end of the Cretaceous period. However, the species' fate as the dinosaur era ended remains a question worth exploring. The twilight of the dinosaur age was a time of great upheaval and evolutionary innovation. Triceratops emerged as the last and perhaps greatest of the ceratopsians. This iconic dinosaur represented the pinnacle of horned dinosaur evolution, a lineage that had flourished for over 100 million years. Triceratops was a relative newcomer to the prehistoric stage, emerging only a few million years before the end Cretaceous extinction event. Yet in this short time, it became one of the most successful and abundant large herbivores of its ecosystem. To understand its significance, we must consider the evolutionary journey of its ceratopsian ancestors. The earliest ceratopsians, such as Torosaurus from the early Cretaceous, were small, bipedal creatures with only hints of the elaborate headgear that would come to define the group. Over millions of years, ceratopsians grew larger, developed more complex frills and horns, and adopted a quadrupedal stance. By the late Cretaceous, diverse species roamed across Asia and North America, each with its own unique arrangement of cranial features. Triceratops, however, stood out even among this diverse group. Its massive skull, which could reach up to 1/3 of its total body length, was a testament to the power of evolutionary adaptation. The efficiency of its feeding apparatus allowed it to exploit a wide range of plant resources, potentially giving it an advantage during times of environmental stress. These evolutionary innovations gave Triceratops a significant edge in the competitive world of the late Maastrichtian. While other ceratopsian lineages declined or went extinct, Triceratops thrived. Its success can be attributed to several factors, including its ability to process tough plant material and its formidable defenses against large predators like Tyrannosaurus rex. Moreover, Triceratops' reproductive strategy may have played a crucial role in its success. Evidence suggests that these dinosaurs reached sexual maturity relatively quickly for their size, allowing populations to recover rapidly from environmental pressures. This ability to adapt and reproduce efficiently likely contributed to Triceratops' dominance in its ecosystem right up until the end of the Cretaceous. As we contemplate Triceratops' place in dinosaur history, we're left with a picture of a highly successful and adaptable creature, one that represented the culmination of millions of years of ceratopsian evolution. Yet even this mighty herbivore couldn't withstand the cataclysmic events that marked the end of the Cretaceous. The same adaptations that made Triceratops so successful in its world may have contributed to its ultimate downfall when that world changed too rapidly for evolution to keep pace. While Triceratops met its end alongside the other non-avian dinosaurs, its legacy lives on in the fossil record and in our collective imagination. The mystery of Torosaurus, a close relative of Triceratops, adds another layer of complexity to this already fascinating story of prehistoric life and death, reminding us that even in the face of evolutionary success, survival was never guaranteed in the dynamic world of the late Cretaceous. The debate surrounding Torosaurus continues to challenge our understanding of ceratopsian diversity in the late Cretaceous. While the basic arguments have been established, the discussion has grown more complex over time. Supporters of the single-species hypothesis argue that the rarity of Torosaurus fossils, combined with the gradual changes in frill structure across Triceratops specimens of different ages, suggests Torosaurus represents the oldest individuals in the species. However, critics offer strong counter-arguments. They point out that the dramatic anatomical changes required to turn a Triceratops into a Torosaurus, particularly the large openings in the frill, are unprecedented among ceratopsids. This raises doubts about the possibility of such major alterations happening late in an animal's life, highlighting the difficulty of interpreting growth patterns in extinct species. The consequences of this debate extend beyond taxonomy. If Torosaurus and Triceratops are the same species, it could lead to a rethinking of ceratopsian diversity in the late Cretaceous ecosystem, which may, in turn, affect our understanding of dinosaur evolution and food web dynamics. On the other hand, if they are separate species, it would raise fascinating questions about how closely related dinosaurs coexisted and partitioned niches. Recent studies have added complexity to the discussion, introducing Nidoceratops as a potential transitional form between juvenile Triceratops and mature Torosaurus. This hypothesis suggests a more complicated growth series than previously thought, underlining the need for a more nuanced understanding of ceratopsian ontogeny. As the Torosaurus debate unfolds, it has provided valuable insights into dinosaur growth and diversity, pushing paleontologists to reassess old assumptions and improve analytical methods. Moreover, it has sparked new ideas about the interactions between ceratopsians and their main predator, Tyrannosaurus rex, offering further intrigue into these ancient creatures' evolutionary arms race. Ongoing scientific debates, such as the Torosaurus controversy, offer valuable opportunities for public engagement with the scientific process. These discussions demonstrate how paleontologists use evidence to form and test hypotheses, illustrating the dynamic nature of scientific inquiry. Such controversies also highlight the challenges inherent in studying creatures that lived millions of years ago, fostering an appreciation for the detective work involved in paleontology. Studies of Triceratops fossils have provided crucial insights into the ecology of the late Cretaceous period, shedding light on how herbivores and carnivores coexisted in prehistoric ecosystems. These findings have implications for our understanding of predator-prey relationships and evolutionary adaptations. Triceratops's robust defenses may have influenced the hunting behavior of predators like Tyrannosaurus rex, leading to the development of specific strategies, perhaps favoring attacks on younger or weaker individuals. As we continue to uncover new facets of Triceratops's life and times, its enduring popularity serves as a bridge between scientific discovery and public imagination. From museum halls to movie screens, Triceratops remains a powerful ambassador for paleontology, inspiring new generations to explore the wonders of Earth's prehistoric past while contributing to our evolving understanding of ancient ecosystems and evolutionary processes. Triceratops, with its iconic horns and expansive frill, showcases the power of evolutionary adaptation in the competitive late Cretaceous ecosystem. The ongoing Torosaurus debate challenges our understanding of dinosaur growth and diversity, reminding us that paleontology is always evolving. As we reflect on Triceratops' legacy, we gain a deeper appreciation for the intricate relationship between environment, adaptation, and survival. This enduring fascination with Triceratops fuels further scientific inquiry, inspiring exploration into the wonders of prehistoric life and Earth's evolutionary journey.